Hello, everyone. Today we will begin the study of a new chapter, Chapter 4, Non-Annual Interest Rates and Annuities. As you probably have noticed, I don't have slides anymore, so we will write everything as we learn. Uh, First, let me begin with a brief overview. So why do we study this chapter? So pretty much we continue what we already studied, like a time value of money. So time value of money and annuities. So on the topic level, we study pretty much the same thing, we did in the previous three chapters. But what's different? So we still study, but we still study time value of money and annuities, but under a different setup of interest rate. Okay, how different is it? Previously, in the previous study, we pretty much we only consider interest paid at the frequency of once a year. So here, year, you can think of it as a period, right? So basically, for all the studies in the previous videos, we either specifically say or implicitly assume interest or payments are made or paid are once a year, right? For instance, when we study annuity immediate, there will be a one payment at the end of each year, meaning there is one payment per year, right? And similarly, in chapter 1, when we study compound interest, we assume interest is paid once a year, right? So now we want to do something different, okay? So now interest may be paid more frequent than once a year. So that is the basic overview. So we live with it, the old problems, but under a different frequency for interest rate. Let's begin with section 4.1 to see what would change. Okay, so we will start with something relatively easy. So we begin with 4.1, that is non-annual interest and discount rates. Of course, we will start with standard interest rate. So let's recap what we already studied, right? In the previous study, we always let interest I or I don't want it to be capitalized. Let I be the annual effective. So here the keyword is effective interest rate. Then we have the AVF given by. So let me switch to writing. So in this case, we already know AVF accumulated value factor at time t will be given by 1 plus I to the power of t. So of course here I assume compound interest, right? So here what I assume is compound interest. Okay, because I work with effective, so technically I don't need to specify the frequency, because you can think I did some kind of magic to change it to effective. The keyword here is really effective. Later on, we will study nominal, and we will compare the difference between nominal interest and effective interest. So this is a basic setup we already know, right? So now let's do something from this formula, right? Because here, so if we write here, t can be anything. T can be anything greater than or equal to 0, right? T does not have to be integer. So T may be not integer. May not be integer. It can be anything. It can be 1 year, 2 years, or it can be 1.2 years, right? So it's 1 year plus 0.2, right? So it can be anything. So now let's consider a special case, okay? So now so usually we let P be an integer. Of course, it's a positive integer, okay? And then we substitute T for, not T, 1 over P for T. In the above formula, we will get the accumulated value at time 1 over P, right? Because P is an integer. So let's say P is 2, then 1 over 2 would be 6 months, right? Because the 0.5 year, it's 6 months. So I can easily write down, so assume your principal is 1, okay? So let's fix principal is $1, okay? Then my account value at 1 over P would be 1 plus I to the power of 1 over P, right? This is very straightforward, right? We have done nothing new at this moment. I just apply the old formula, but at a fractional time, right? Because here we assume P is an integer. So if P is 2, I want to know my account value 6 months from now. If P is 4, right, then it's 1 over 4. So it's 3 months. So it's 1 quarter from now. Depending on the value of P, right? Then we have different interpolation. But anyway, this is our account value if we start with $1, right? So we normalize, that doesn't matter. So under this condition, this would be your account value at time 1 over P. Okay, now assume your question is, let me write down the question. So now what we do is, suppose we deposit $1 at time 0 and withdraw the entire account amount at time 1 over P. So our question is, what is the interest rate for this investment? So when we calculate interest rate, that would be the amount of interest divided by the principal or the initial amount, right? So with that in mind, the interest rate, it's very easy to calculate, right? I mean, how do you calculate? It will be, so let me write, it will be the end value minus the starting value, and then divided by the starting value. Of course, because it's 1, we don't really need to do the division, but I write it anyway to show you how interest rate is computed, right? So this is the interest rate. The rate I will earn, or we will earn, over 1 over P period, or over P years, because we usually set year as the unit period, right? This is the interest that we earn, okay? We are not talking about for the effective over per year, because here I is the effective over 1 year. Here, this is the interest rate we earn over 1 over P years, all right? So now our national question would be, so let's first do a quick example. So let I be 7%. So if you put $1 at your account, 1 year later, you will get $1.07. So that's the meaning of effective interest rate per year. Okay. What do we want for P? So let's say P equals 12. So 1 over P would be your account value in 1 month. Okay. So let's do the computation. 1 plus 7% raised to the power of 1 over 12 minus 1. Okay, we can quickly do the analysis to the computation. It's 0.5654. So over 1 month, this is your interest rate. So this is the interest rate for 1 month. Okay, so I is the interest rate for 1 year. So the interpretation is very straightforward, right? So if you put $1 at your account, 1 year later, you will get your $1 back plus 7 cents as interest. If you put $1 in your account for 1 month, 1 month later, not only you get your $1 back, you will get some tiny cents, $0.00565 back. Okay, that's the meaning. So both are in the sense of effective. Okay, the meaning of effective again is straightforward because there is no hidden fees. 7% gives you exactly how much interest you will earn over 1 year. So the thing is, you must match exactly this this time interval to get this interest. So in order to get 7%, you need to put your money in the account for exactly 1 year. Similarly, for this, you need to put in a saving account for 1 month. So you should match this time. Okay. So next, what we want is, of course, if you earn this monthly rate, but accumulate for 12 months, you will get to 1 year. So they are equivalent, right? Because I derived this from 7%. So they are equivalent. Next, we have something different. Let me introduce another rate. So this is what you earn in 1 month, right? In 1 year, what you earn, there are 2 ways to calculate, right? One way is to raise this power, so it will be 1.005654. Okay, this will be my account value in 1 month. If I raise this to the 12th, I will get exactly 1.07. That is because I do compounding, right? So I apply the same thing down here. So of course, I'm supposed to go back to the original annual effective interest rate 7%, right? So, but this gives me 7% for 1 year. Another idea is I don't want to do the compounding thing. I don't want to raise to the power. Can I try this? This is for 1 month. I directly times by 12. See what I have. So you can get your calculator to see what the number you have. I get this number. So this is actually less than. Okay, so this is not exactly the interest you will earn if your account can give you compound interest at higher frequency, let's say once per month. So, but if you think this from a different angle, so here we are talking about depositing, right? So this gives us higher rate, right? Higher than 6.78%. But in most business, when we talk about interest rate, we are actually borrowing money from the bank, right? Let's say you take a student loan, or later on when you buy a house, you take out a mortgage. You will also see an interest rate, right? They do not quote you on 7%. They actually quote you on this. So they quote you on something smaller, okay? That does not mean they charge you small fees, okay? So this apparently between 6.78% and 7%, all of us will go with the smaller number, right? Because that number represents our costs. The higher the interest rate, the more we pay to the banks for borrowing money from them, right? So that's why, you know, in the business, people don't quote this. So business do not quote 7%, they quote this percent. But however, when they calculate the cost, is effectively 7%. So that is somehow, you know, the tricky part behind this, which we will learn. That's what we call the nominal interest. So this is what we call. We already know 7% is the effective. This is nominal. So this is the nominal interest rate. I believe we will have the formal definition for this, or at least at some point we will have the will have this. Okay, um, in a few minutes we will discuss that. So this is the quick difference. So once nominal interest rate is quoted, what you do is you actually need to divide by the frequency to get the effective interest rate over a single frequency. So here is 1 month, right? And then you raise to the accordingly to the time of the year. Example 4.1, determine the biannual effective interest rate that corresponds to an annual effective rate of 8%. That's relatively easy. The only term is the textbook also mentioned biannual. So this means twice a year. Okay. What I usually prefer to use is semi-annual. Okay. The reason is because there's another name that could cause potential confusion. That is, well, it pretty much reads the same. Biannual. This means once every 2 years. Okay, so biannual and biannual, well, they read pretty much the same, right? But this means once every 2 years. So you get one payment every 2 years. This means you get one payment every 6 months. So you can see, you know, the difference is rather significant, right? In mathematically speaking. Example 4.1, I leave that to you. So it's basically P equals 2 and I equals 8%, right? So you do the easy calculation. Next, we do the discount. Discount is always, well, you know, a little more complicated than interest rate. So first of all, what we need is, let me type. So we have something similar, okay? We still let P be an integer number. And the D, well, as usual, it will be the annual effective rate of discount or discount rate. By now, you should know the various relations between D and some other random variables like I, like V, right? So there are many interpolations, right? So for instance, interpolations. interpretations. Interpretations of D. So basically, one way to understand it is the present value of interest, not interest rate. Although here it's with I with unit principle, you know, it's the same, the present value of I. So from that you get D equals I divided by 1 plus I. So sometimes it automatically capitalizes the letter. Of course, this is 1 minus V as well. So there are different ways to express, right? So now what we want to study is of course, you know, it's the discount, not the future value. So assume you borrow $1 for 1 unit period, say 1 year. The net amount payable at the beginning. So let's say because from here what we know is the PV factor. So PV factor at time t would be 1 minus d. Okay, raised to the power. So I put you know this little head t. So this is how we calculate the PV at any time t for $1. It's basically how we discount, right? So now similarly to what we did for interest rate, we take t to be 1 over p. So now take t to be 1 over p. So the present value at 1 over p would be 1 minus d to the power of 1 over p. Okay, so what it means is if you take out $1 loan. Now we used to analyze for 1 year, right? So this is what we used to do. Okay, but we no longer do it. What we do is from 0 to 1 over p. Right. So now that's what we do. So this is the, well, you can think this as the net amount borrowed, right? So what is oh, let me erase everything because this could be slightly more complicated. So let's do a slightly more complete analysis. So let's begin with what we already know. Okay, so this is what we studied before, old things. You borrow $1 at time 0, you pay 1 plus I, right? So 1 is principal, I is interest. But if I want you to pay everything at 1, at 0, so this would be, let's separate this, okay? So we know I, if I discount back, it would be D, right? Exactly the present value of I, okay? 1, obviously discount to V, right? So add those back, so D plus V equals 1. So there are several ways to understand. Here I give you another understanding. So what we do is effective loan. So if interest is paid at 0, the effective loan is 1 minus D, right? So basically what you do is you want to borrow $1, okay? But I want you to pay me the interest right at the time of borrowing. So instead of giving you $1, I will only give you 1 minus D because I implicitly take D dollars out for interest. Okay, so you only get 1 minus D from me. By the end of 1 year, you pay me back $1, no longer 1 plus I, because you prepaid your interest, right? When you take out this loan, you didn't get $1. You only got 1 minus D at time 0. Okay, in the future time, you pay back $1. So from here, what we can say is the discount is 1 minus D. Of course, mathematically it's trivial, right? But we want the economic meaning. So $1 is the original size of the loan. So this is the original size, right? When you walk into a bank, you fill out application, you want to borrow $1. So 1 minus D is the amount of money you walk out from the bank. So when you walk out from the bank, you have 1 minus D in your pocket. So, but on paper, you are obligated to pay back the bank $1. So the difference is your cost, right? So that's another way of understanding discount rate. Now let's do everything the same, but it's not for 1 year. It's for 1 over P year. Okay. Well, pretty much things are similar, right? So you probably still want to get $1, but your effective now would be 1 minus D, right? So because that is the present value of $1, then we know you still want to borrow $1, right? Then what would be the thing you need to add here to make 1? Because that is how we define discount rate, right? So this is the effective loan. This is the nominal loan or original loan. The difference would be the effective rate or effective discount rate over, so this is effective discount rate over 1 over P, yes. Okay, D is the effective discount rate over 1 year. All right, so of course this P can be any integer. So, well, if you take P to be 1, then it goes back to this case, right? But of course, we can take P to be a different integer. We can take P to be 2. That means we only want to consider for 6 months, right? It's very possible, right? And since we know the difference or the relation between D and I, we can put it back for this formula, right? So we know 1 equals the present value to this I. So we can write down a formula: 1 minus D to 1 minus 1 over P would be 1 minus 1 plus I to the negative 1. So if you want, you can put a box to claim this is a formula, if you want to say. Okay, we have an example that you can do, right? So here we have a D to be 7%, and we still want D is 7%, P is 12, so it's on a monthly level. So you can calculate the effective discount rate. Okay, do this calculation. So I leave that to you. Example 4.2 is somehow similar. Example 4.3. Okay, let's do this. This is This is more interesting. Example 4.3. We want to know the present value of payments, $35 at the end of each month for the next 24 months. So let's draw the timeline. Okay, so here the unit is not year, it's month. So here 1 stands for the first month, here is the end of second month, this is the end of 24 months. We have value 35 at each time point. So this is a symbol, right? This is actually a level annuity immediate. So using our terminology, this is level annuity immediate, because all the payments are made at the end of each period. Here, unit period is months instead of year. The annual effective interest rate. So what we have is I. I is 5%. So what we can do? Again, when we work out the pricing formula or present value formula for annuity, we don't really care about the unit, right? Whether it's year, it's months, it's a quarter, we don't care. What we care about is the discount for that unit period, right? So previously, U equals 1 divided by 1 over I. This is the discount for 1 year. Now, our unit is not year, our unit is months. So we want something for 1 month. How do you get the discount factor for 1 month? So do we have any notation for that? Well, we don't have. So let's say, let me put a tilde. Let's say this is the discount factor for 1 month. Okay, so that means, what it means is v to the -1, right, would be the AVF at 1 month. So here let's put this. Okay, that means this is the AV at 1 month. Okay. What we have is not for 1 month. What we have is for 1 year. So this accumulate for 12 months is 1 year, right? And it should be 1.05, right? So from here, what we can get is, so we will do, so we will have okay. So basically, that would be the if you don't like this, you can, well, you can always apply the let's don't do this, because let's just use what we just derived, because we have everything. Because now we have P is 12 and I is 5%. So we can get the monthly interest rate, right? Using the formula we just worked with, 1 over P, so it's 1 over 12 minus 1. So this is about 0.4%. So this is the monthly interest rate, okay? And then we know how to do the discounting, right? So it's 1 over 1 plus the monthly interest rate. So this is how we do the discounting for 1 month. So this is the discount factor for 1 month. Okay, now let's write down the present value for this stream of payments or annuity immediate. The first one needs to discount back by 1 month. The second one needs to be discounted back for 2 months. So raise the power, right? So you can think this as a new annuity, but if we want to use our old notation, here would be 0.4074, right? Because that is the effective interest for unit period. This is not for unit period. This is for 1 year. So in this case, unit period is 1 month. 1 year is 12 periods. So you will need to convert this interest rate to the unit interest rate. So once you have done the conversion, you can apply the old formula 1.004074 to negative the n, which is 24, divided by your interest rate 0.004074. So it's close to $800. So 798.69. Okay, so that's let's do one more example from the textbook. Example 4.4. We want to know the AV. Okay, so right now we want to accumulate the value of $540 per year paid in equal installments at the start of each quarter for 5 years. So there are 4 quarters in a year, so there will be 20 payments. So let's draw this first. At the start of each quarter. So the first payment is here. Amount is 540. Here is the first. So the last is paid at 19. So here the unit is quarter. So 3 months. Okay. What do we know? We have D. So in this example, we have the annual effective rate of discount, 6%. Okay. So sorry, I made a mistake. So this is not 540. So 540 is per year. So you need to divide by 4, right, to get the payment. So is 1, 3 times 20. So 4 times 5 is 20. So each payment is 135. Okay. Then we are pretty much at what we used to do, right? This is an annuity due. So now the question is, what we're going to do to convert everything into for 1 month, right? Okay, so let's do it. According to our previous result, so first of all, we need to find out the quarterly. So it's 1 minus D 1 over P. So this is the effective quarterly discount rate. So 0.94. Okay, so 1 over 4. So we get it's 1.5350%. This is the quarterly effective discount rate. Okay, so obviously this is annual. So that is the difference. Okay, once we know this number, we can pretty much get to what do we have, right? Because let's do one more step to convert this to the corresponding interest rate, right? So the relation between I and D is I equals D divided by 1 minus D. So plug this for D because that we really need new notation for this. So let's call this I tilde, okay? So let's call this D tilde. Later on, we have some notation. So let's say I tilde would be the quarterly effective interest rate. So it will be D tilde divided by 1 minus D tilde. The result is about 1.5589%. So now we know the question is to calculate AV at this point, okay? We want to know the AV at this point. So this is 135. So this is annuity due, so we put double dots, and this for the accumulated value, so it's S. There are 20 payments, so A is 20, but the interest rate is not what you get from 6%, it's what you get from here, 1.5%. So it will be 1.5589%. Okay, so I believe you can carry on the computation. It's about $3,188. Okay. So let's finish this video with some notation. Okay, that's much needed because I don't want to put tilde all the time. So now what we introduce is, so first of all, let's introduce IP. This is nominal annual interest rate. Okay, and that means we have a frequency P times per year. Okay, by this, what I mean is the effective interest rate over 1 over P a year is this divided by P. So in other words, this corresponds to actually my earlier example, what I did here. So in this example, on the right-hand side, so this 6.78% is what I just introduced as IP. So this is, on the right-hand side is what I just introduced as IP, the nominal interest rate, okay? And this nominal interest rate divided by P, in this example, P is 12. If I divide by P, what I get is exactly the effective interest rate per month, because here, month is my unit. Or this IP divided by P would be the P's, well, effective interest rate, right? Because sometimes it's not monthly, it could be quarterly, it could be semi-annually, depending on the value of it, okay? So one thing we immediately know is the effective interest rate is bigger than, right? This, again, you can use the previous case, right? So here, the effective interest rate is 7%. The nominal interest rate is 6.78%. So you do have this relation. I just wrote down, okay? This is called I upper P over P. Well, usually I just read it as I to the P's. Well, or we can just call it the nominal interest rate, okay? For the same reason, we can also define EP, okay? And the dP over P would be the effective discount rate. Discount rate for over 1 over P. This is what I call the tilde, right? In the previous examples, the symbol, you know, this is nominal annual interest rate. This is obviously nominal discount rate, right? At the frequency P times a year. So that's good for the for this video. Let me stop here.